Welcome everyone to this lecture on using NumPy for indexing and selection. Let's hop over to a Jupyter notebook and get started. Okay, so the first thing I'm going to do in this notebook is say import NumPy as NP, and then I'm going to create an array using just NP arrange, and we'll say from 0 then up to but not including 11, so that should get me 0 through 10 as an array. Okay, let's talk about bracket indexing and selection. So the simplest way to pick one or some elements of an array is actually pretty much exactly like we did with a Python list. You can grab the array and use bracket indexing to grab an index location. So for example, if I want the element at index 8, I just ask for index 8 and it returns 8. In this case, it matches up perfectly because the first element is 0. If you actually want to get values in a range, you can use slice notation, which essentially follows the exact same thing as a Python list. You include the starting location, colon, and then up to but not including the last index. So this should give us 1 through 4. If you want to get everything up to a certain position but not including it, we can do colon 5, and that will give us 0 to 4. And likewise, you can do a starting position up to the end, and that gives you 3 all the way to the end. So bracket indexing and selection works exactly like a Python list or even a Python string. Broadcasting is another topic we're going to talk about. So NumPy arrays differ from a normal Python list because of their ability to broadcast. So let me show you what I mean by that. If we look at my array, I have 0 through 10. What I can actually do is broadcast a reassignment. So I can actually grab a slice of this, let's say 0, 1, 2, 3, 4, and I can set that slice all equal to 100. And you can't do this with a normal Python list. So now if I ask for that array back, I end up seeing that these first 5 elements here, 0, 1, 2, 3, 4, are now all the number 100. And this is known as broadcasting. So let me reset that array, because note that the change is actually permanent here. We'll go 0 to 11. Now I check out my array, it's back to normal. So what's important to note here is that if you have some sort of variable that's assigned to the slice of an array, for instance, we'll say 0 colon 6. So if I check out the slice of an array here, I have those first elements. And if I reassign this, so if I say slice of array, and then I say, okay, select everything, that's just a simple colon, select everything in that slice, and set that equal to 99. If I check out the slice of my array, I have everything 99. If I check back on my original array, notice that that slice was essentially just a pointer to that first half of the array. So it actually changes the original array as well. So we can see here that the data is not actually copied, it's just a view of the original array. And the reason for that is to avoid memory problems. A lot of times when you work with NumPy and then pandas as well, it's built on top of NumPy, you're going to be working with pretty large data sets, and you don't want every single variable assignment to create another copy of your data set. Otherwise, you would quickly run out of RAM if you had really large data sets. So instead, if you actually explicitly want to copy, you need to say so. So you need to say something like this variable, array copy, or previously that slice, is equal to array dot, and then you call copy. So now if you check out this array, it's 99, 99, 6 through 10, and if I do something to array copy, such as grab everything and set it equal to 200, my array copy has been changed, but my original array is still that same thing. So you have to explicitly call copy if you want a copy of your array. Okay, let's talk about indexing a two-dimensional array, otherwise known as a matrix. The general format for indexing an array looks something like this. You have some two-dimensional array, or let's just call it mat to make it like a matrix, and then you end up saying square brackets, the row you want to index, and then the column you want to index. So again, it's going to be row, comma, column. The other way you can do this is by actually splitting it up into steps. So you can say bracket row and then bracket column. So that's for indexing. Let's show you a couple of examples of this. I'm going to create an object called mat, and we'll say it's an NP array. And let's actually just make this be a nested list. So we'll say 5, 10, 15. Next item in this list is going to be 20, 25, 30. And then finally one more. We'll say 35, 40, 45. So note here I'm just passing this nested list into NP array to get back a matrix that looks like this. So 5, 10, 15, 20, up to 45. Lots of ways we could have made this matrix. This is just the simplest doing it manually. So let's say I want to index an entire row. I end up saying mat braces, and then I ask for the index position of the row I want. So if I want that very first row, 5, 10, 15, I just pass in a 0, and that returns back that very first row. If I want that last row, that's going to be 0, 1, 2, so we pass in 2, and that gives me back that very last row. If I want to actually grab an individual element value, the way I can do that, there's two ways. Let's say I want to grab, let's just take a look at our matrix real quick. If I want to grab 25, how would I do that? Well, I can say mat, it's at row position 1, and then as another set of braces or brackets, I can say the column position, which is again 1, so 0, 1. So it's in the first row, or it's in the index 1 row at the index 1 column. And that gives me back 25. Now more commonly, you'll actually see this done in one step, like this, 1, 1. So typically this is the way you'll see it done in examples in the documentation. You'll use this comma notation instead of this dual brackets, because this comma notation will also expand to slice notation. So let's try this one more time. And what you should do is pick a number kind of in your head, pause the video, and see if you can index it out using this comma notation. So let's see if you can index out 15. Go ahead and pause the video and try that yourself. Okay, I'll do it now. So if we look at 15, what row is it in? Well, it's in row 0. And what column is it in? It's at index column 2. And there you have 15. So let's talk about 2D array slicing. If we take a look at our matrix again. All right, so to do slicing, what you end up doing is, let's say we wanted to grab 10, 15 here and 25, 30. So we wanted to grab this little square, 10, 15, 25, 30. The way we would do that is we say the rows we want as a slice. So basically, I want everything from the first row, 0, up to but not including index 2. So I can say colon 2. So as far as the rows go, grab everything up to but not including 2. So that's rows 0 and rows 1. And then I actually want the similar aspect of the columns themselves. For the columns, I want to start at column 1, or column index 1, and then go all the way to the end. So 10, 15, 25, 30. So that's going to be start at column 1, and then go all the way to the end. So if I do this, then I get back 10, 15, 25, 30. Okay, so go ahead and try to pick out another square and see if you can index it. See if you can index out 20, 25, and then 35, 40, this little square right here. I'll do that right now as an example. So 20 and 25, what rows are those in? Well, that's going to be rows 1 and 2. So we can say the following: start at row 1, go all the way to the end. Those are the rows, and then for the actual columns, well, that's starting at 0 and then going up to, but not including index 2. So then that's going to be basically the opposite. And there we can see we have 20, 25, 35, 40. Essentially the reverse of what we did on the first one. In your Jupyter Notebook that goes along with this lecture, there's a couple more indexing help examples. We won't actually do stuff like this too often because we'll mostly use pandas and named indices. This is just kind of to get your brain in the mode of thinking of two-dimensional slicing. But as far as the actual syntax, we won't use it that often. Instead, what we're mostly going to be doing is something called conditional selection. And this is a really fundamental concept that will directly translate to pandas in the next section. So make sure you really understand this specific part. This is a really important topic, and it's called, again, conditional selection. So conditional selection. And to show this off, we're going to create an array, and it's just going to be np_arrange, and we'll say 1 to 11. So if we check out our array, it's just 1 through 10 there. So let's imagine that I wanted to grab elements off of this array based off some sort of comparison operator. I wanted to grab every element that was greater than 4. The process for doing this is the following. I can actually compare my entire array to the number 4. I can say, where is this array greater than the 4? And it returns back this array of Boolean values, where the first few ones are false. So 1, 2, 3, and 4 are not actually greater than 4. However, 5 and beyond are greater than 4. So you get true here. So this is an array of Booleans. And then what I can do is I can assign, we'll say Boolean array. I can assign that result to this Boolean array. And then I can grab my original array and then pass in that array of Boolean values. And what it ends up doing is it only returns the array where the Boolean values happen to be true. So again, I'm getting this Boolean array greater than 4, setting it to this Boolean array, and then passing that in to my original array. And it ends up returning only the values where the index location matches true here. So that's how I get 5, 6, 7, 8, 9, 10. Now typically you actually don't separate this out into 3 steps. Instead, what you commonly do is the following. You grab your array and then say, okay, give me back where the array is greater than 4. And you get this sort of notation where you see array twice here, once inside the braces and once outside the braces. And you get back the exact same result. And this is what's commonly done when you're working with NumPy and pandas. And this is known as conditional selection. So you can do the same thing for any sort of comparison operator. You can say, give me back where the array is less than or equal to 9, and you get back 1 through 9, etc. So again, conditional selection, we're going to see this a lot, and we'll get a lot more practice with this when we work with pandas. And that's the basics of selection and indexing with NumPy. If you have any questions, feel free to post them to the Q&A forums. Thanks, and I'll see you at the next lecture.